All right, this will be a quick tutorial as far as the origins of the quadratic formula, this beast of a formula that will help determine the solutions to any quadratic equation that you will be given. A, B, and C represent the coefficients of the standard form of a quadratic equation, being ax squared plus bx plus c. And so this is really just kind of where it comes from. So we're going to work backwards, where we start with the quadratic formula, and I'm going to show you what this would end up being if you were to kind of take everything of this mess and move it to the other side of the equation to show you where this actually comes from. It will be a familiar equation. So I'll just go ahead and jump right in. So if I was trying to move everything over here across this equal sign, I got to do it using inverse operations. And the first object to move would be this 2a in the denominator. It is dividing into this mess up top. So the way I would move the 2a would be to multiply both sides by that 2a. And this is what would happen. And so by multiplying the 2a by x, I'd get 2ax. And now it's gone from the denominator here. Great. All right, still got to move a bunch of stuff. So the next thing that would be the logical thing to move would actually be this negative b that's being added or subtracted to this radical. So in order to move this negative b, the inverse of a negative would be to add that object to both sides. So if I add b to both sides, I get this result. And so in this result, you'll notice I have that same 2x, and now I've added the b over here, and now I just have a radical here on the right-hand side. And this plus or minus is going to go away in just a second. So let me slide this down a bit so we can kind of just keep rolling with it. All right, so now the thing I want to get rid of, the thing I want to move over here, or at least get rid of, is this radical, the square root. And the opposite of a radical, in this case, the opposite of a square root is to square that side. And that's ultimately why this plus or minus is going to go away. Because when I square this radical, whether or not it's positive or negative, when I square it, if it's a positive times a positive, it stays positive. If it's a negative times a negative, the negatives end up canceling. So when I square this side, I just have to make sure I do the same thing to this whole side. This is where it's going to get a little messy, but I'm going to square both sides. And so when I do that, this is the result that I'm going to get. All right. Now the radical has gone away here, as well as that plus or minus. So I'm just left with what we'll discuss as what's called a determinant. This is what's left over underneath the underneath that radical. But now I have to square this side because that was the inverse of that radical. Now what I'm going to end up with here, this is where, again, it gets a little messy, but this is stuff that we have done before. This is just going to be like what we did in chapter 2, where now I'm taking some binomial, and when I square it, that means I'm taking that 2ax plus b and multiplying it by itself. And so 2ax plus b times 2ax plus b. I'm going to skip through a little bit more of the intricacies there, but this is the result that happens when I distribute and collect like terms. Just quickly talking through it, 2ax times another 2ax would end up squaring each of those terms, right? 2ax times b would give me a 2abx, but then when I square this times itself, I'd have a b times 2ax as well. And when I add them together, I'd end up with that middle term. And lastly, the b times itself would give me the b squared. So this is just the distribution and collection like terms part of that same element squared. So this is, as I said, messy, to say the least. But let's keep going. I keep wanting to move this stuff to this side of the equation. That's kind of the purpose of what I'm going to do here. So what I would do next is I'm going to move this b squared. Now this is a positive b squared, so the way I would move it would be through subtraction. If I subtract b squared from both sides, you'll find that both will end up canceling. And so once I subtract b squared from both sides, I now have this new statement. The b squared is completely canceled and gone. And so now I have one more object to move onto this side of the equation, and that's this negative 4ac. And so because it's a negative, the way I would move it from this side over to this side of the equation is by addition. So if I add 4ac to both sides, we're going to see where this goes next. And some of you may actually already start to see where this is going to be going. But if I add that 4ac over to this side, I now have this statement. Sorry, got a little messed up with the paper as I'm sliding it across. Let me just kind of fix some of these. There we go. All right. And so I now have this mess over here on the left-hand side of the equation. 4a squared x squared plus 4abx plus 4ac equals 0. All right, so I've successfully moved everything away onto this left-hand side of the equation, and that's all well and good. But here's the other thing I want you to notice. Each of these terms, this is what we would call a 3-term polynomial, a trinomial. And in each of these individual monomials, they do have something in common. Each of these terms has a 4, and each of these terms has an a in common. So I can actually factor out 4a from each of those terms by division. This was a strategy that we learned in chapter 2, how to factor out something from a polynomial. And when I do that, I now have this statement. Getting a little messed up with the paper as I was moving it. And so by pulling 4a out from each of these terms, this should be pretty familiar at this point. And so when I pull 4a out of 4ac, I'm left over with just c. When I pull 4a out of 4abx, I'm just left with the bx. When I pull 4a out of this, the 4 is gone, and one of those two a's is pulled out, and I'm left with just ax squared. Okay, and so I have 4a factored out of that trinomial. And so what I can technically do at this point is I can do the reverse of what I did before, where I can move this 4a over to this side of the equation. Okay, so this will be a little bit more backwards, but if I were to take this 4a, it's multiplied by this trinomial right here. So if I were to move it by dividing on the left-hand side, dividing by 4a, and then if I were to do that on the right-hand side, 0 divided by 4a, well, 0 divided by anything stays 0. And so when I do that, this is what I'm left over with. That is where the quadratic formula actually officially comes from. So ax squared plus bx plus c is the standard form of any quadratic. It is a quadratic officially because of this x squared element. This is, again, just the standard form. A, b, and x can represent literally anything, any number, any constant. But this is my standard form of a quadratic. And basically, what we did in reverse, going from the quadratic formula, was got back here. Technically speaking, if you wanted to create or invent the quadratic formula, we would go the opposite direction. So whatever mathematician out there first created this might have started by saying like, all right, well, if I multiply everything in this equation by 4a, I would get to this element right here. Now, if I were to distribute that 4a throughout that trinomial, I'd end up at this mess here. Well, at that point, I can move this 4ac over to this side of the equation. And the reason why they would be motivated to do this is they're trying to get x by itself. They're trying to solve for x. And so if I subtract the 4ac over to that side, now I get to this step. Now, if I keep going that direction, maybe I add in this b squared element onto both sides. Pull this up. All right. And so if I added a b squared element onto both sides, now what I could do is I can factor this guy, because this is now what we would call a perfect square trinomial. We just dealt with that in section 4, completing a square by adding in this b squared element. So completing that square, now I can factor it into this form. And now what I can do is I can get rid of that squared by taking the square root of both sides. And what we learned is that if I take the square root of a number, that I get this plus or minus result when I do that. And so I'd have what was inside of that parentheses right there left over, and I have the square root of that plus or minus, and I could subtract the b. And again, the whole purpose of doing this is now I'm trying to isolate that x. All right, so if I move the b away through subtraction, I get this negative b plus or minus that what was originally taking the square root of. And now again, I want to move stuff away from this x and isolate it, so I would divide both sides by that 2a, and that is where the quadratic formula actually comes from. Not that you'll be tested on it, but still, if you're like me when I was in high school, you were kind of curious about that kind of stuff. But for right now, I'm going to stop recording.